Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's GFG problem of the day, shortest prime path. So we will be given two prime numbers, okay, num1 and num2. What we want to do is we want to calculate the minimum number of steps or the shortest path to reach from num1 to num2. Okay. So we want to return the minimum steps or the shortest path. So if you see here and the next number, right, we choose, right, from in order to reach from number 1 to number 2, right, also should be prime numbers. Okay, so if you see here, in order to reach from 1033 to 8179, so first we go to 1733, right? So this is also prime number. Then we go to 3733, then we go to 3739, we go to 3779, okay, 8779, and then 8179. Okay, so this will be the path. This is the shortest path in order to reach from num1 to num2. Now how we can solve this problem? Okay, so what we can do is we can pre-compute the prime numbers. Okay, so the max number given here is, if you see, right, if you see here, so the max number given here is the number 1 and number 2 can be, minimum can be 1000 to 9999. So what we'll do, we will calculate the prime numbers from 0 to 10,000, right? 0 to 10,000, or basically the max number is 9999, right? So we will calculate, we will compute, we will store all the prime numbers from 0 to 9999. Okay, and then, okay, so we'll do this. Then the next step, what we'll do is we will, once we have all the prime numbers till this 4 digits, right, the max 4 digits, then we will modify. We'll start with the num1, right, the num1, and we'll modify each character. We'll try to modify each single character, right? What they're saying is that can be attained, right? The shortest path also need to be attained by altering only single digit at a time. Okay, such that every number is a 4-digit prime number. So we'll modify each single digit, and we'll check whether that number is a prime number or not. And how we'll check? Because we will be having the pre-computed. We'll check in the pre-computed prime numbers, right, whether this number is a prime number or not. Okay, this number is a prime number or not. So in this way, if it is done, for example, now we found that 1033, after 1033, right, 1033. Now what we did, we modified this bit, right, 0 bit, 1733. If you see 1733, right, and now we are checking, right, once we modified this 0 to 7, and we are checking in this prime numbers, right, in the stored prime numbers, whether this is a prime number or not, right? If it is a prime number, also what we'll do, we'll have a step variable, okay, which will be 0. So whenever we find a prime number, right, we'll increment the step, right, 1. So here, for example, right, if we come here, so we'll increment the step. Okay, this is a prime number 1. Now again, we modified what? 17332, single digit modified was, this 1 was modified to 3, and this is a prime number. So we'll have each step, we'll store each step, right, until we reach the number. So once we reach the number, we'll return the step. Okay. So first let's see how we'll pre-compute the number. So pre-compute the prime numbers, right? So we are going to use sieve of Eratosthenes. Okay, sieve of Eratosthenes algorithm, right? So for example, let's say we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. For example, we have these 20 numbers, right? So we want to calculate the prime numbers. We want to find out the prime numbers till 20, right? Till 20. So what we are going to do? So simply, what we'll do is, how sieve of Eratosthenes algorithm runs is, we'll have a buffer, an array. Okay, a buffer, a big buffer. So we are going to have, in our example, we are going to have a buffer till of 10,000. Okay, of 10,000. Okay, constant, right? That's this, the maximum number is 9999. So we'll have a buffer of 10,000. Now first we will fill this array with as true, like all the numbers are prime number. Okay, and then what we are going to do is, definitely prime of 1, right? Prime of 1, that is the number 1. The number 1 is not a prime number, so we are marking this as false. Okay, now then what we'll do, we'll start with I equal to 2. Okay, we'll start with I equal to 2. Okay, and we'll check here whether this prime of 2 is prime or not, right? Is prime or not? Yes, it is prime, because we have marked, right, all the elements as true, right? Yes, so this is true. This is a prime number we are saying. And then once we have prime number, right, so what we'll do, we will go to the multiples of 2. Go to the multiples of 2 and mark them as prime number as false, because they are divisible by 2, right? So they are not prime numbers. So the multiples of 2 will be 4, 6. These are not prime numbers. We'll mark it as false. Okay, these are not prime numbers. Okay, in this way we'll go, right? Right, once done, right? See here, if you see here, we are going in the multiples of I, right? This internal for loop, right, is right, marking false is marking the ith number, right? Multiples of ith number as false. Okay, so this 4, 6, 8. So all this job is done by this internal for loop. Okay, and then what we'll do, we will go to the next number now, prime of I, right? So I will be 3 now. I will be 3. And similarly, again, we'll go to the multiples. Now we'll check whether this prime of I, prime of 3 is true, right? Yes, it is true. Then what we'll do now, we'll go to the multiples of 3, right? And we'll mark them as false. So again, 6. 6 definitely is marked 9. Now 9 we are marking here, right? This is not a prime number, right? 12 is already marked. 15 is also not a prime number because it is divisible by 3, right? It is multiple of 3, right? So similarly, in this way, then we'll go here. This will check. 4 is definitely, we'll check here. 4 is not a prime number, right? So we won't go inside. 4 is not a prime number. I equal to 4. Then I equal to 5. Yes, it is a prime number. Then we'll go to the multiples. We'll cancel out all those multiples of 5. Okay. Similarly, in this fashion, we are going to go till 10,000. This is just an example, right, of 20 numbers. In this fashion, we're going to go till 10,000. And we have a prime numbers, which are true, right? Okay. So now, once this is done, now what we're going to do is, see here, they're asking us shortest path, right? Shortest path. So whenever the shortest path comes, then BFS comes into the mind. So we are going to use BFS, right? So what we'll do is, now, in the BF, we'll have one queue. Okay, we'll have one queue, right? And we are going to mark, we are going to put number 1, pair of number 1, right? What is number 1? So in example, for example, number 1 is 1033, right? And we'll step, as I told you, we'll have a step variable. We'll have a pair of these two numbers, and we are going to push in the queue. Okay, this is the queue. Okay. Now once done, what we're doing is, see, what we are also going to have a Boolean visited array. Okay, and then what we'll do, we'll pop this out. Okay, we are popping this 1033. Okay, we'll pop this out. Sorry, this one. Yes, and then what we are doing is, we are checking whether this pop number is visited or not, right? Is visited or not, right? This pop number is visited or not? No, it is not visited. We'll go ahead and we'll mark it as visited. 1033. We have removed this, right, from the queue. We'll mark it as visited, and then what we'll do is, we are calculating here what the from number to string we are okay, typecasting. Okay, or converting. Fine. And then what we're doing is, see, we know the digits are 4 digits, right? So what we'll do is, each character, now 1033 we have, right? So what we'll do here, see here, what we're doing, we are going to have, we want to modify, right? We want to modify and check. We'll take this first bit or first digit, right? First digit, and we are going to check. We are going to change to 1, 2, 3, 4, 5 till 9, right? Till 9. Okay, till 9 we are going to check, right? 2033. We are going to modify one single digit at a time. Okay, one single digit at a time, and then we are going to check each number whether this is a prime or not. If it is a prime, then we are going to push in the queue. Okay, we are going to push in the queue. Okay, and we'll also increment the step. Okay, from 0 to 1. So for example, right? So this is to try all the characters, right, from 0 to 9. Okay, and I is for each. We know that for it will be 4-digit number. For each digit, we have to right, replace with some other, from replace a number from 0 to 9. Okay, so here we are checking whether if, right, for example, 1033, right? So if this is the I now, right? Now J is also going to start from 0 to 9. So if J is the same as I, right? J is same as I. So we want to continue. We don't want, because it is the same character, right? Or same number. So there's no point in checking that. Okay, and definitely there shouldn't be any leading zeros, right? There shouldn't be any leading zeros. So if I is 0, right? I is 0, right? If I is at 0th location and J is also at 0th location. So we don't want to modify this one with 0, right? 0033. We don't want to have this because we don't want leading zeros. Okay, so that is why these are the checks. Okay, we'll continue if these are the conditions matched, right? Else we'll go here. What we are going to do is, now, for example, 1033, right? So now we found that this particular, right, when we no, what we're going to do is, now we will create, for example, let's consider this one, right? So what we're doing here is, we are modifying, right? Okay, let's take this example, 1033 and this particular digit, right? Now let's consider 7. So what we're doing here is, see, now this is, we are taking substring till I. Substring till I, we have took this, plus we are, J is, for example, 7, right? J is 7, and plus the remaining string, right? Plus the remaining string 33. So this we are doing 1733. This is a new string form, and then we are taking the number out of that, and we are checking whether that prime, right? Prime is what? Are this pre-computed array, right? We are checking whether it is a prime number or not. If it is a prime number, then we are adding in the queue. Okay, and we are also incrementing the step. So, right? So whenever we find the next number, right? So we are going to increment the step, right? So once this is all done, we will go again here, right? So this time we'll check, and this time the number will be 1, and then we are going to increment the number 2. Okay, so in this way we'll reach till the end number. So here we are checking whether once we have reached, right, our num is reached, when we remove from the queue, and if it is number 2, then we are returning the step. Okay, here we are returning the step. Okay, so this was the Java code, right? And let's see C++ code as well quickly. So this same again, right? This same again, the C of Eratosthenes, right? we are pre-computing the prime numbers, and then we are having q, right? So here we have inbuilt pair, right? Inbuilt pair. So we don't have to write pair class like in Java, right? And then we are having this visited array, Boolean array, and then we are running whatever I've explained. It's almost same, right? We are we're going to pull out, remove from the queue, and then we are going to check whether it is num2. If it is, then we are going to return, right? And if it was already visited, we are going to continue. We are going to mark that as visited. If it is not visited, then again we are going to modify each character, each bit, right? Each character, each digit, and we are going to check if it is prime number. Then we are going to push in the queue, and we are also going to increment the step. Okay, so this is the intuition solution, right? Let's quickly run the code. Now let's run Java code. So Java code here we are having extra pair, right? Pair of a class, first and second. Okay, so we are using the same here pair. Okay, let's submit this. So yes, it is accepted. I hope you've got the solution. Thanks for watching. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you. Thank you so much.